Hello everybody, I'm Radu, I'm Quector Field Application Engineer. I support Southeastern Europe and we will discuss today some insights about narrowband technologies, and I will do a live demo with BG96 module in Vodafone's NBIoT network. Let's start with something you know, how 2G technology works. So have a 2G module. When you first power it on, it will require a high current peak up to 2 amps to search the network. Then we'll attach and transfer the data, and it transitions into listening state. If you have a battery powered application, you may want to cut off the power, so power of the device, to save power consumption. This sequence will repeat each time the module will wake up. So search for the network with high current peaks, and then go to power off again. So it will consume a lot of power when it searches the network due to these high current peaks. If you compare it to low power wide area technologies, first difference is that current peaks are much lower, so 8 to 10 times lower than 2G. Usually it's 250 milliamps. This is maximum. Usually, typically it's 200 milliamps. Another difference is this PSM mode, which means power saving mode, that it is integrated already in the device, and the device is sleeping, not powered off, while still consuming very low power, below 4 microamps, so comparable to leakage current of a switching transistor. But let's see what happens more in detail. Similar to 2G, when the module is first powered on, it will search the network, but with lower current consumption, and they will register and attach to the network, send some data, remaining in some idle mode where it just listens to the network, and then instead of powering off, it will switch itself in this power saving mode. So you don't need a switching transistor. It will go to deep sleep where consumption is very low, and next time it will wake up, it will not search the network again. It will just do a short sync with the network to see if the cell is still there. If there is data to send, it will send data. If not, it will go to idle again, listen from data from the network, and after a while it will go to back to sleep again. So this will repeat each time. If the module wants to wake up to send some data, it can wake up anytime, send the data, and then repeat this cycle. But what's important to note here is that registration is one time only, so consumption is reduced due to this limited time when the module searches for the network. This is because such devices are supposed to be stationary, so same cell will be available also next time after the wake up. There are some timers. One is called idle time, when the module is listening to data from the network, and the big one is called traffic update time, which includes the PSM time. Actually, PSM, the difference between this traffic update time and the idle time. And this idle time can be extended, so now it's 2.5 seconds, can be extended up to 40 minutes, which means if you don't want to use PSM because the module is not reachable in this time, you can extend this DRX time. DRX means discontinuous reception. So the module will still be reachable each 40 minutes from the network side. This is the maximum setup, but still have a lower power consumption than compared to standard usage. This EDRS time can be up to 44 minutes for Cat-M1 and up to 3 hours for NBIoT technology. Okay, let's focus now on BG96 module. It supports 3 different networks: Cat-M, Cat-NB1, and 2G. It also is multi-band, supports multiple bands and different protocols. At application level, it supports LWM2M protocol and MQTT, 2 very common protocols used in IoT industry. And you can actually write your own code inside the device using ThreadX and QAPI from Qualcomm. For tracking applications, it includes a GNSS with low noise amplifier integrated, Power range is from 3.3 to 4.3 volts. Consumption in this power saving mode is 10 micrams for this module, but for BG95, which is next generation based on different chipset, this will be 3 micrams in power saving mode. Okay, now let's go to testing. For this, we'll use the BG96 simulation board, the kit with antenna and cables and so on. You can find documentation following this link. On the laptop, we'll use the QCOM application, which is a serial terminal. You can use any serial terminal that you have. You can get this one from the link shown here. And for the UDP server, we'll use one that is in my office, running on Raspberry Pi. Has this fixed IP and is listening on this port. So this is the test architecture. Module sends UDP data to the server, server replies back. This is how it tests the UDP works. Then the server is also a client, MQTT client, that will publish this data to an MQTT broker, a free broker called Cloud MQTT. And then using your own laptop or smartphone, you can connect the same broker, subscribe to this topic, and you will see actually live data from the module. This is how the page looks like. So this is the link. You will need access to see live data from the module. And second test will be MQTT. So we'll publish directly from the module MQTT messages to this broker and see it on the web client. So this is how our EVB looks like. This is the box. Let's see what's in the box. Flyer with instructions how to connect and some accessories. Some are optional. This is the evaluation board itself. First, connect the RF cable. Make sure it's connected tightly. Then screw the antenna. And finally, the module on a TA adapter board. Snap in on the two connectors. Then connect the RF cable. This is more delicate, so take care. Okay, now I will connect the USB serial cable. This main UART on the left. Then for power supply, we will use USB on the bottom. We can also use standard DC adapter, but 5 volts, not standard, the one provided in the box. Now put a SIM card before you turn on the module. And this is the board. Okay, this is the live demo part of the webinar. You can see here the QCOM application already up and running. Let's load some scripts from here. I created for you a script with the comments already set up, so you don't have to type anything, just click these buttons. But first, open the communication port, turn on the power of the board, and press the power key to turn on the module. Wait for the module to boot up. Okay, module is up and running. Now we'll execute some commands here on the right to change some default values of some parameters. So the device will search and attach to NBIoT network faster. So first command, set the band to band 20 for Vodafone Romania. For other operators, check with them what band they use and check the manual what value to use here for that band. Next one, change network scanning mode to LTE only. Change network scan sequence to NB1 to have priority over Cat-M1 and 2G. Change IOTP operation mode to NB1 only. And change service domain to PS only, because LTE only uses a packet switch domain. Now enable some notifications. This one enables notifications when the module is registered to the network. This one enables notifications when module is disconnected or connected from the network. And finally, this one will notify when the PSM timer expires. And all those notifications will use UART1, because UART1 port is used for AT comments in this example. Now turn on the module and set the APN. This value is very important. for the device to work. So APN is you can get it from operator, specific to each operator. Next one, execute manual registration to Vodafone Romania on 9 means NB1 network. So module is already registered. We got OK here. It may take some time until you get OK. So don't execute other comments until you have an OK here. Next one, we can check some status. So this is actually these are 4 comments online. CGAT means 1 means module is attached. CREG1 means module is registered. Some network information, so CAT NB1 network, Vodafone Romania on LLT band 20, and this is the channel number used. And this command will output the IP address of the module, IP assigned from the network. Now let's activate the PDB context. When we work with data, we need to have a PDB context active. And now open a connection to a server. So this is a UDP connection to this server, to this port. Actually here on the left is a window that will show us live data to this remote server. Okay, now we'll send some data, we'll send some text information encoded as hex to this comment. Its data is received by the server, showed here. This is a public IP from the server, and we got here a URC, meaning we have incoming data on socket 0. So use this comment, read data on socket 0, and they receive 24 bytes, and this is the actual data. What we sent was replied back from the server. This is an echo server, and now we can close the connection. So this is a simple test to show UDP data sending and receiving on NBIoT network with BG96 module. Now we will make a test for direct MQTT data sent from the module side. Let's switch first on this window. This is an MQTT client connected to an MQTT broker server. Subscribe to topic temperature. Okay, so we'll make a connection to the same server. It's connected. Now we'll authenticate with username and password. We're okay. We subscribe to the same topic temperature, and we got the same value because now the module is also client to this network and subscribe for this topic as the left window. But now we'll publish on the same topic. So publish on topic temperature. This command will open an input, activate the input mode, and we need to enter here the value by hand. So change it to 21, and now we need to do Control Z. So characters 1A in hex, it's Control Z, and now the data is published, and you see it's already updated on the server side. And because we're also subscribed to the topic, we get the same data back. Now you can close the connection. So this is it. This is how you send data using MQTT protocol with BG96. Thank you for listening. We are waiting now for your comments and questions.